Hi everyone, welcome to Focal Academy. In this problem, here how to find current I1 and I2 by using mesh analysis. So here two voltage sources are there, that is 40 with phase angle 30 volts and 50 with phase angle 0 volts. So by applying mesh analysis, how can you find the current and I1 I2 for the given problem? Here total two meshes are there, this is one mesh and this is another mesh. So here for a voltage source, the current direction is from positive to negative. So in the first mesh, that is from positive to negative. The given direction and the actual direction of the source is same. So in second loop, the current direction is from positive to negative in this direction. So but given here opposite direction. Now write the mesh equations for the two loops. So first of all I am going to write mesh equation for the first loop. The source voltage is 40 with phase angle 30 degrees volts. That's equal to the voltage drops in inductor and capacitor which are in this loop. So in these two components there is a current I1 is passing. So it can be written as I1 into inductor impedance is J10 plus minus J20. Here minus J20 is the impedance of capacitor. Next minus of any external currents are there. Yes, there is a current I2 was entering here in capacitor. So minus of due to current I2 in capacitor, that is minus I2 into capacitor is minus J20. Next here in this loop the current direction of from positive to negative, the given also same. So take here plus sign, no change. So 40 with phase angle 30 degrees, thus be equal to here J10 minus J20 nothing but minus J10 I1 minus of minus plus J20 I2. Now take 10 common in the RHS, you will get so 10 into minus J I1 plus J2 I2, thus be equal to here 40 with phase angle 30. So 10 ones 10 fours. So it becomes 4 with phase angle 30, thus be equal to minus J I1 plus J2 I2. So it can be written as here, so 4 with phase angle 30, thus be equal to minus J I1 plus 2J I2. So let's consider this is equation 1. Now similarly write the mesh equation for the second loop. So here this is the voltage source, so that is 50 with phase angle 0 degrees, that's equal to sum of voltage drops in this loop. So here having resistor and capacitor is there. So current is I2, it is I2 into I2 was passing through resistor and capacitor. So resistor is 40 plus and capacitor is minus J20. So there is another current externally, that is I1 was entering here in capacitor. So that is minus of I1 due to current I1 take as minus. So I1 was passing through capacitor, that is minus J20. So here the current direction is given as the opposite. So actually the current direction is from positive to negative in this direction, but given negatively. So that's why I take here minus. For source take the minus. So it becomes minus 50, thus be equal to, take 10 common. So 10 into I2 into 4 minus J2. So 10 4 is 40, 10 2 is 20. Equation is balanced. Next here also take 10 common directly. So minus become plus. So plus I1 into J10. So J2. So 2 into 10 20. 10 is common. 10 ones 10 fives. So take minus to the right hand side, then it becomes 5 thus be equal to minus I1 2j minus I2 4 minus 2j. So let's consider this is second equation. Now we have two mesh equations are there. That is equation 1, equation 2. So by solving these two equations, we will get I1 and I2 value. We have different positions are there for calculating I1 and I2. That is, one is the elimination method or Cramer's method. Now here I am going to use Cramer's method for finding I1 and I2 here. So take this one to be upside. So next, write the matrix form. So for equation 1, I1 coefficient is minus j. So that is minus j, and I2 coefficient is 2j from equation 1, and from equation 2 I1 coefficient is minus 2j, and here minus of 4 minus 2j. So into I1 into I2, and corresponding constant is as. So for the first equation, the corresponding one is 40 with phase angle 30, and for second 5 is there. Now find det for this matrix. So that matrix det is, let consider as delta. So thus be equal to, we will get 4.472 with phase angle 116.56. So just I am using calculator for finding the det for this in the Phasor form. Now we want det 1 and det 2, means delta 1 and delta 2 values. How can you find it? So delta means det of this matrix. So in this matrix, so replace first column, means in the place of first column, so take these values, keep second column as it is. So for that, delta 1 is 21.01 with phase angle 211.8 degrees. Now similarly, keep first column as it is. Now change second column with these elements. So these elements are going to be replaced here in the second column. Now at that time find that matrix that we will get 4.44 with phase angle 154.27. Now according to Cramer's rule, we know that delta 1 by delta gives the first variable, that is delta 1, means I1. Next, delta 2 by delta will give second variable, that is I2. So substitute here, delta 1 is, this is 21.01 with phase angle 211.8 upon, and delta is, this is, that is 4.472 with phase angle 116.56. So by simplifying this, we will get a value that is 4.698 with phase angle 95.24. So this is I1, units are amperes. Now similarly find I2, that is delta 2 by delta. So delta 2 is, this is, that is 4.44 with phase angle 154.27 upon, and delta is 4.472 with phase angle 116.56. So by using calculator, we will get that I2 value thus be equal to 992.8 with phase angle 37.71 degrees milliamperes. So this is amperes and this is milliamperes. So this is the current I1 and this is current I2 for the given problem. So this is the process of calculating currents, that is I1 and I2. So by using mesh analysis, so for the given circuit. And thanks for watching. Please subscribe, like, share. Thanks.